All right, so we're going to use concepts of similar triangles and proportions in this lesson today. The first thing that we're going to do is we've got two kind of tasks, and the first thing we're going to do is talk about how to divide a segment into a given ratio. So I'm going to give us two examples here. The first one, and I'm actually probably going to do question 10 here with you. It says they want us to divide the given segment such that the ratio applies from A to B. So basically, they want me to divide this so that if I put a point P somewhere on this line, AB, we want to put that point somewhere so that the segment AP is in a ratio of 3 to the segment PB, which is in a ratio of 2. Okay, so the first thing that I think here, or that I notice, is that I'm trying to divide this really into 5 equal parts because I want a ratio of 3 to 2. So the first thing I'm going to do is divide this into 5 equal segments, and if we had a ruler we could do this perfectly. So I'm just going to estimate 1, 2, 3, 4. That is not the most equal, but I want a ratio of 3 to 2. And once I do that, I should see that if I put P at this spot right here, I've given myself a ratio of 3 to 2. All right, let's look at what this looks like on a coordinate plane. So for example, question 5, they're asking me to do the same thing, except this time they're giving me specific coordinates. All right, so the first thing I'm going to do is go ahead and plot these points so I can see what my segment looks like. So as with the previous example, I know I need a ratio of 5 to 3, which means I'm going to need 8 total sections. So what we want to do here is count the slope and see if our slope runs in a way that lets us group this into 8 equal sections. So I notice here that my slope is -1. So I'm going to kind of just look at that every time. And if I count that slope over and over again, that gives me 1, 2, 3, 4, 5, 6, 7, and it does actually give me 8 total sections, which makes this pretty easy. I'm going to move from A to B, and so counting from A to B, I want to count 5 sections. So if I do that, I'm going to see section 1, 2, 3, 4, 5. So this point right here, -1, 0, is where I want to put my point P. So I'm going to go ahead and put that there. And then I can just double check that does give me a ratio of 5 to 3. All right, so the second part of this lesson is talking about how to use indirect measurement, which is just a way really to measure using similar triangles, to measure things that are difficult to measure. So there are 3 different methods or types of way that you could actually use these in real life. So the first one is finding an unknown height using shadows. So if you want to like label that as using shadows. So they've given us an example here. They've given us 2 things, and you can pause and read this. They're talking about, we're trying to figure out the height of a palm tree, which would be difficult to physically measure, right? To physically get out a tape measure and measure how tall that is, you would have to probably climb up that. So instead, we can create a similar triangle and use similar triangles to measure something. So they're saying here we could use a meter stick because that's a meter long, and we can compare its shadow and create a ratio between the meter stick itself and its shadow. So these 2 triangles are going to be similar because the angle of the sun is going to be the same for both, and these are both right triangles, so these are similar by angle similarity. And if we go ahead and solve these, then I can set up a proportion for how these are equal. So if I set up a proportion with just the side lengths, that's XY is proportional to AB, and then ZY is proportional or related to CB. All right, now we can go ahead and set up and plug in the actual values we know. So that's going to give me 1 over, I don't know the palm tree's height, so I'll call it H. They tell me to find the height of the tree H, equals 1.6 over 7.2. And then to solve this, we've kind of already done this. We can just talk about cross multiplying here. So that's going to give me 1.6H equals 7.2, and then divide. All right, and here I'm getting that the height of the tree is 4.5 meters. So just by knowing those things, we could figure out that the height of this palm tree is 4.5 meters. All right, another way to do indirect measurement is to use a mirror. So if for some reason we couldn't measure our shadows, or if that was more difficult, we can also place a mirror in between, which is going to, because of reflections, so if I zoom in here just to show you, because of reflections, these two angles against the mirror are going to be congruent. And then we're going to be measuring things. We measure things perpendicularly. So again, these are similar by angle-angle similarity. Now, I can also set up a ratio here to solve this. So I'm going to do 6 over 5. Or if we want to do kind of what we've been doing, I'm going to say 6 is the height of the person, and I'm going to compare that to the height of the cliff, which I'll call x in this case. All right, so the person corresponds with the height of the cliff. And then I also know that the person's, like the distance the person is from the mirror is the same as the distance the person is from the cliff. This might be helpful, you know, the next time you're in the desert, measuring how tall a cliff is and the sun's at high noon and there are no shadows, right? So if I do 6 over x, when I set up the other side of the proportion, it's going to give me 5 over 60. And then I just, same idea, I'm going to cross multiply those. So when I do that, let's see, that's going to give me 5x equals 360. And then divide by 5. I'm pretty sure I'm going to get 72, but let me check myself there. And 72 is right, so that means that the height of the cliff is 72 feet. All right, so again, next time you're in the desert, hanging out with a mirror, and the sun's at high noon so you don't have a shadow, you can use this method to figure out how tall something is. All right, and this last method is used, as you can read here, is used when you're trying to find how far something is, how wide something is. So you're looking at like a horizontal distance, not maybe how tall something is, and there is some sort of physical barrier or a reason that you cannot directly measure this distance. Okay, so for example, in this particular example, we're talking about the distance across a canyon. That's not something that you can like measure straight across. So what I want you to do real quick is just pause the video and read steps 1 through 4 and see if you can make sense of where the things are coming from in the picture. All right, and now that you've done that, it did take me a minute too to kind of make sense of what it was saying. You should see that these are going to be similar triangles. I've got vertical angles here in the middle on part Z. Those are not transferring well. Sorry, I've got vertical angles on angle Z there in the middle, and then I have 2 right angles. So these are going to be again congruent by angle-angle similarity. And then I can just set up my proportions. So 600 corresponds to this 400, so I'm going to do 600 over 400 equals, let's see, what is that, 327 over, I don't know the distance across the canyon, so I'll call it D. And just like we've done with the others, we can cross multiply this, so 600D equals 200, oh, I'm sorry, that's not right, equals 130,800. I'm going to multiply the other way. And then go back and divide by 600 to get D by itself. And I'm going to get D, which is the distance across the canyon, is 218 feet. So that's a way that you could measure how far across that canyon is. All right, so make sure that you have these notes and examples with you for tomorrow, and then we'll work some problems together.